The first part of plotting any graph is figuring out the scale. So given the information in question 1, we know that's a graph of f versus e. That means that f is going on the vertical or the y-axis and e is going on the horizontal or x-axis. So we need to get a scale for each of these axes. And the process of going through it is taking the maximum value from each scale, each axis, and dividing it by the amount of blocks, the amount of CM blocks on each axis itself. So let's deal with the y scale first. From the table, the maximum value of y, which is your force, is 21.6. So you divide in 21.6 divided by the maximum blocks, which is usually 24. You can double check that. And when you divide this, you get 0.9. So that means that every block is worth 0.9. But that is not what we call in physics an appropriate scale. Appropriate scales in physics would be 1 to 1, 2, 2.5, sometimes 4, 5, 8, and then back to 10, 20, 25, and so on. So usually when we calculate this value by dividing, we scale it upwards to get a more appropriate scale. So when you scale 0.9 upwards, the closest number is 1. So every block or every 1 cm block on your y-axis is 1 or 1 Newton. For the x scale now, the maximum value of x, which is your extension e, is 12. There are about 18 blocks. You have to double check sometimes, but there are usually 18 blocks. When you divide it, you get 0.66 recurrent. So that means that every block is worth 0.66, which is not an appropriate scale. So we scale this upwards. The next closest value to this is 1. So every block on your x-axis is going to be 1 centimeter because this was your extension and the y-axis was your force. So we can now go to the plotting. So here I have completed both axes. So as you see, every 1 cm block increases by 1 on both axes as the scales were so set. I am now going to label a couple of things before I actually start plotting. So I usually put you do have to put a title to the graph. The title is usually what the question asks you to plot. In this case, it was a plot of force versus extension, or in symbol form, which is allowed, F versus E, that goes at the top. For each of the axes, you also put the label as to what is being plotted, not just y and x, but the actual quantity and its unit. So your y-axis is your force measured in newtons. You need the two things together. And the x-axis is your extension measured in centimeters. And that label can be put anywhere along the y and anywhere along the x. Each 1 cm block is made up of 5 smaller blocks. So using a little calculation, 1 divided by 5 smaller blocks, each of the smaller blocks are worth 0.2, both for y and for x. So if you need to get a 0.2 value, that is what we can use. We count the smaller blocks. If you need to get 0.1, well, if 0.2 is 1 block, then 0.1 is half of a small block. So let's start plotting. The first step in plotting is you choose your choice of symbol. In physics, we are allowed 2 symbols, an X or a dot, small dot with a circle around it. I shall use the latter. So the first point is 0, 0. 0, 0 is your origin. I put a dot by 0. I put my circle around it. I am working with E first and then F. So the next point, E has a value of 1.5. So I'll identify where 1.5 is. It's between 1 and 2. And it's actually halfway across. So to get 1.5, I'll check 1, 1.2, 1.4, and to get 1.5, which is 0.1 extra, it'll be halfway in between. So it's 2.5 blocks to get my 1.5. And I can make a mark here just to remind myself of where it is. The force value for this is 2.7. 2.7 will be between 2 and 3. So again, I count using the smaller blocks. From the 2, 2.2, 2.4, 2.6, and if they get 0.1 more, so they are 2.7, it's 3 and exactly a half blocks. So I can use my ruler now to kind of guide me. I'm not going to draw a line, but I'm just using it as a guide. So I line up against this, not along the line, but along the actual halfway mark. And I check back against my y. I need to get 3.5 blocks. So from here, it's going to be 1, 2, 3.5. And I double check. This is 1.5, yes. This is 2.7, yes. That's my second point. My third point, the e value, the x value is 3, so that's easy. That's just here, 1, 3. And I need to get 5.4 for the force, which is your y. 5.4 will be 5, and then every small block again is 0.2. So 5.2, 5.4. So again, I can use the ruler as a guide. I put line it up with the 3, just to give me an idea where to go up. After go to 5, and then go 2 small blocks up, because every small block is with 0.2. So that is my 5.4. The next point now is 4.5 for E. 4.5 again, that's halfway between 4 and 5 on the E scale. That will be 4.2, 4.4, and then to get 4.5, I have to go half of a block. That 4.5 is against 8.1. 8.1, the 8 is for your force, here is 8. Remember, a small block is worth 0.2, so to get 0.1, I have to go up half of a block. So again, I can line up. I go a little extra to get a little space. I check up to where 8 is, and then I go up the half a block to match against that. I put my dot. I draw my circle. So the circle itself is not a huge circle. It's not as big as a grid. It's fairly compact. The next point, the E value is 6. So that's straightforward. And that 6 is against 10.8. So 10.8 will be between 10 and 11. So I check. Every small block is 0.2, 10.2, 10.4, 10.6, and this is 10.8. So it'll be 6 against 10.8. I use my ruler as a guide. I go back to 10, and I count 4 blocks up. Or you can check it as 1 block under 11. So that's my 11, 1 block under. That's my 10.8. Next point, 7.5. By now, I should recognize the pattern. It's 2.5 blocks, 1, 2, 2.5, or 7.2, 7.4, 0.1, which is half a block. And the 7.5 is against 13.5. So I have 13, 13.2, 13.4, 13.5 will be half a block. So it's over there. So I line up, and the ruler must kind of be bent. It has to be straight to line up. As here's my 13, and I check 2.5 blocks going up. 1, 2, 2.5. So this point here is my 13.5 against 7.5. Next point is equal 9. That's just a straight value there, the 9, and that's against 16.2. To get the 0.2, we should know the pattern by now. That's a small block. So that's 16, and you go one small block above. So from 9, I'm going straight up. Here's my 15, here's my 16, and I go 1 block upwards. That is my 16.2. And then I have 10.5. So 10.5, again, the pattern to get 10.5 is exactly in the middle between 10 and 11. 2.5 blocks out of 5. I have to get 18.9. 18.9 is between 18 and 19. 18, 18.2, 18.4, 18.6, 18.8, and to get the 0.9, which is 0.1 more, it will be half, or half less than 19. Remember, half a block is 0.1, so 19 minus 0.1 gives you 18.9. So I check my 10.5 here. I line it up. I check one block under 19. For me, that's far easier to do. I make my mark. Sorry, it will be here. And I draw my circle around it. And then the last point now, I have 12 against 21.6. So 21.6, 21, 21.2, 21.4, 21.6. So 3 small blocks up to get 0.6. The 12, I line it up. And I check from my 21, 2, 4, 21.6. Now in this particular graph, the points are exactly lined up. In real life, these points may have a variance because these reflect experimental data, so some points may be off. This particular graph we are plotting is Hooke's law. Hooke's law will always start from the origin. So I start with my 0 point on my ruler. I line up the points as best as I can. In this case, it's a perfect graph. And I don't just draw to the last point, but I draw and extend beyond it to the edge of the grid. And that is my graph here. So this was part A, to plot the actual graph. You make sure you have your heading, your title of the graph. Each axis has a label. Each axis has a good proper scale. The points are either X's or dots and circles. You plot them correctly. You draw a line with a long ruler and not a short ruler that you then extend. It has to be a long ruler. Okay? So moving on to the next part now, we have to deal with the gradient. Now to find gradient, we have to use 2 points from the graph for a particular calculation. Gradient in physics, you cannot use any points that you plotted from the table. So I can't use any one of these points. I have to use 2 new points. One should be close to the start of the graph, and one should be close to the end. And how I'm choosing, I'm looking for a point that falls along an intersection of any of these lines, a vertical and a horizontal intersection. So I can start from the origin and I see a point here already, right over here. And you notice I'm using X because I choose to use a different point for my gradient points. So this was 1, 2, 3 small blocks across. 3 small blocks is 0.6 because X always comes first in a coordinate, and the Y value is 1. I don't have to put no units. Another good point I could have used, if I'm checking, could be over here. Possibly even this one as well. All of those are viable points. But I already have a good one that is even lower. And then I check towards the edge of the graph, and I work my way downwards until I find a convenient point that is exactly on a grid line, like say this one. So this one, if I follow down, that's after 12, that's okay. I know after 12 will be 13 and then 14. And it's actually between 13 and 14. So that would be 13.2, 13.4. So the X value is 13.4. And now I check my Y value, it's above 22, this will be 23, and then this will be 24. So this one is slightly above 24, so it's 24.1 block above. Yes, 1 block above, so it's 24.2. Right? So I mark the points here so that I can see it and identify and double check it, and also for an examiner as well. And now we can go to the calculation. For the gradient calculation, we use a standard formula, but before that, a good practice I encourage is writing down the 2 points that we have it in mind. So it's 0.6 and 1, and 13.4 and 24.2. You can also identify that this is x1, y1, the x value, y value, and this is x2, y2. Just to kind of guide you along. Because to find gradient, the formula is as follows. So y2, take away y1, over x2 take away x1. And that's where the x values and the y values come from. So y2 take away y1 will be 24.2 minus 1, and I put it in brackets because I want to avoid a bombast error when using the calculator. And x2 take away x1 will be 13.4 minus 0.6. Now the other part of this is that in physics, gradient has a unit. And if we go back to the graph, we check to see what y is measured in, not the quantity, the unit, and what x is measured in. So y on the graph was measured in newtons. I'm not going to turn back, but it is measured in newtons. So this number, those are numbers measured in newtons, and the x now, they were the extension measured in centimeters. This is newtons divided by cm, because this thing here gives you the unit of your calculated answer. Alright, and then we put this in our calculator using the brackets, and when we do work it out, we get 1.8125. But here's the thing. In physics, we don't need all these significant figures. In fact, you can sometimes have a calculator giving you 10 digits. We normally round off to 3. So 3 will be 181. After the 1 has 2. That will not change anything. So the actual answer is 1.81 rounded off. And the unit now, the newtons remains as is. But because the cm was underneath, when it comes on top, the power will change to cm minus 1. So-called newtons per cm. And this, of course, is measured to 3 significant figures, right? And that's your calculation for your gradient. But see now, you are given a force of 12 newtons, and you need to find the extension for it. So we're going back to the graph for that. So we identify which axis is the force axis, in this case the vertical axis, and they want to know the extension for a force of 12. So from 12 on the force axis, you're drawing a line, a dotted line, and part of the marks is, yes, showing this line on the graph. And you draw the dotted line until you reach the actual graph, and then you'll bring it down vertically. So if you notice, my one is between 2 blocks, so I'm going to have to do that. It's halfway. Don't suddenly have your line going bend, it has to continue going exactly straight. So you can start at the top or start at the bottom, whatever is more comfortable for you, but again, dotted. Right, so it's a value between 6 and 7. It's 3 whole blocks, so it's 6.2, 6.4, 6.6, and then half a block. This will give you 6.7. So for the question, your answer for a force of 12 newtons, you can just write it as your answer. E is 6.7 centimeters. And that is your question 1.